Hi, everybody. As you might be able to tell from my voice, I am sick. I will not be at school today, presumably, if you watch this on Tuesday. Right now, it's Monday. Making a video is kind of the last thing on earth I want to do right now because talking kind of hurts. But I got to get this done because I'm not going to make it tomorrow, as hopefully you learned when I wrote you an email. I think it was Sunday night. Anyways, we won't meet in class this week, Tuesday or Thursday. The next time I see you will be a week from Tuesday. So the next time I see you will be November the 15th. And instead of coming to class Tuesday and Thursday this week, watch this video and the one that I'll send you in a few days. This week, like every other week, we kind of go over these two different sections, 4.2 and 4.3. Today I'll go over 4.2. In the next video, I'll go over 4.3. And then we'll talk about both of those on the quiz. Big picture, the idea for 4.2 is, in 4.1, we learned about exponential functions. So functions that are of the form y equals a times b to the x power. In 4.2, we're going to deal with those exact same functions, except now we're going to focus on, well, the graphs of these functions. And what you'll see, what you've hopefully already seen if you watch the videos that I made on this section, is that to understand the graphs of these functions, you really just have to understand the value of a and the value of b in this equation. The value of a always tells you the y-intercept, and the value of b, I don't have a great name for it. It's kind of like the slope, although it's not the slope, because the slope is a term that is reserved for lines, and these graphs are curves. But it's kind of a measure of steepness. Maybe I could say it's slope-like. And importantly, it's always going to either be between 0 and 1 or be greater than 1. And I think the easiest way to keep track of these two different cases is think about what happens when you go to the right on your graph. When you go to the right on your graph, if b is greater than 1, the graph is going to be moving away from the x-axis as you go to the right. When b is between 0 and 1, well, the graph's going to be moving towards the x-axis. That's all very general, but for the first few homework problems, what we talk about are more specific graphs, where really you don't even need to know any of this stuff. You can come up with the graph without any of that. Let me show you how. So this first one, we have this function, f of x equals 5 to the x power. If you want to think about it as a times b to the x power, then a is the implied 1, because this is 1 times 5 to the x power, and b is equal to 5. So my y-intercept should be 1, and I should be moving away from the x-axis when I go to the right. That's all true. But I can't just go draw on my graph kind of like this arbitrarily, because they gave me this specific equation. I got to make sure I go through the right points. So what I want to do is kind of think about some input-output pairs. When I put 0 into this machine, 5 to the 0 power is equal to 1. So 1 would come out of the machine. Therefore, it must go through the point 0, 1. When I put 1 into the machine, 5 to the first power is 5. So 5 should come out. It should go through these 2 points, which is all that I need to sketch the graph. At least I think that's true. I think they give you a graphing tool, and I think you click on it and give it 2 points, and it'll draw the rest of the graph for you. But in case it doesn't, when the x value is 2, the height would be 25, so way off my screen down here. Each time I take one step to the right, I multiply by 5. So each time I take one step to the left, I divide by 5, meaning this height should be a fifth, and this should be 1/25th, and 1/125th. And now we're getting so close to the x-axis that I can't even distinguish it from the x-axis. My graph should look something like that. But I don't think you need to draw that. I think you just need to select 2 points on the graph, and it does the rest for you. Note that with a equal 1 and b equal to 5, we do have a y-intercept at 1, and the graph goes away from the x-axis when we go to the right. Question 2, same idea, except now the a is equal to -1 and the b is equal to 5. The trick here is students look at this and they think -5 is being raised to the x power. This is not -5 to the x power. B is not -5. B can't be -5 because b is always between 0 and 1. A is -1, b is 5, and that's important when you're trying to sketch this graph. And yeah, sure enough, you click an icon and then click 2 points on the graph. So even if you didn't know this stuff, I think you could still figure it out this way. Aha, and I even put in this hint right there. Look at that. You could tell I've used these problems before. Question 3, same idea, except now the value of a, the number out in front here, is neither 1 nor -1. So in this case, a is 2 and b equals 3. Come up with the graph, take a look at that graph and be like, oh yeah, the y-intercept is at 2, and it's moving away from the x-axis when I go to the right. 4, kind of the same idea, except now b is a value between 0 and 1. So a is the implied 1 that's right here, and b is equal to 1/2. And what you need to do is plot a couple of points to come up with the graph. When you're doing this one, you got a couple of options. I mean, the most obvious point, the one that most students will use, is this one right here, right? When you put 0 in, 1 comes out, because 1/2 to the 0 power is equal to 1. But for your next point, I think a lot of students would think about what's the height when x equals 1. And if you do that, you'll get a height of 1/2. And you can use that, but it doesn't work super nicely with the graphing tool, because if you click a point that's actually 0.45 instead of 0.5, it might throw things off. So rather than try to pick this decimal, it might help to pick this whole number. Wait, how'd you know that that was 2? Try putting -1 into this graph. 1/2 to the -1 power is 2, so it should go through this. Each time I take a step to the right, I multiply by 1/2. So each time I take a step to the left, I divide by 1/2, aka multiply by 2. What if I gave that as a hint? Doesn't look like I did this time. Anyways, it goes through all 3 of these points, but when you're graphing, it might make your life easier to use these 2. Question 5 is more of the same. The idea here is b is again between 0 and 1. It's 1/3 in this case, and a is equal to 3. Plot some input-output pairs. Maybe you could find 2 that give you integer values and come up with the graph. The first 5 questions are all kind of the same, and hopefully you can do each of them in like less than 30 seconds. The idea is just to get a lot of practice graphing these and kind of start to see some patterns when you're graphing them, because the whole section, we're really just supposed to get comfortable with the graphs of exponential functions. It's not the most challenging section, and it's hopefully one that won't take you super long. Question 6 looks a little bit different from the rest. Question 6 is actually what I modeled your quiz off of this week. So your quiz isn't exactly question 6, but it's this idea where I sketch a bunch of graphs for you, but it's not obvious what the equation of the graphs are. And what you have to do is compare their values of A and their values of B, maybe talking about which ones are the largest or the smallest or the same, or order them somehow. So when you're doing these problems, I think first of all, it's easier to look for A than B. So which graph has the largest value of A? Well, if you know that A is the y-intercept, hopefully you can just look at this and tell which one has the largest y-intercept. For B, it's a little bit more challenging, but remember, for B, we're talking about it's either going to be between 0 and 1 or greater than 1. Anything greater than 1 is obviously greater than anything that's between 0 and 1. So what I'm looking for when I'm looking for the largest value of B is something that goes away from the x-axis when I go to the right. If I'm looking for the smallest value of B, I'm looking for something that goes towards the x-axis when I go to the right. So if I look at these graphs, there's 3 of them, green, black, and red, that go away from the x-axis when I go to the right. So when I'm looking for the largest value of B, it's got to be one of these 3 right here. But how can I compare their values? Well, B is also how much you multiply a given height by each time you take 1 step to the right. So note that red and black have the same height right here, but if I take 1 step to the right, black is higher up than red is. So black must have been multiplied by a bigger number than red got multiplied by. Similarly, black and green have the same height here, but when I take 1 step to the right, black is higher than green, so black must have been multiplied by a number bigger than green got multiplied by. So black is bigger than red, black is bigger than green, and because blue and orange, I guess, go towards the x-axis, black is bigger than both of them as well, so black must have the largest value of B. Same logic more or less works for the smallest value of B. I guess if I've gone this far, I should just finish the problem. For the smallest value of B, it can't be any of these 3. It's got to be one of these 2, because these 2 are less than 1. But which one of these is it? Well, blue and orange have the same height right here, but when I take 1 step to the right, orange is a number that is smaller than blue is. So orange got multiplied by a number that was smaller than blue got multiplied by. Therefore, orange must have a smaller value of B than blue does. That's question 6. It's what your quiz looks like, and if I remember right, the next few problems are kind of the same. Question 7, same idea, least, greatest values for A's and B's. Question 8, sort of more of the same, except here instead of asking for least and greatest, they put in numbers. And you're like, yeah, but the numbers are really ugly. Right, but you're not supposed to use the actual numbers, right? You notice that 4 of these 5 graphs have the same value for A, and one of them has a different value of A, and that value of A is bigger than the other 4. So maybe just by looking at the values of A, we can immediately figure out which graph is the orange graph. And then maybe after you've eliminated that one, you can start looking at the values of B. And you might notice that 2 of the remaining values of B are greater than 1, and 2 of the remaining values of B are less than 1. And you're like, well, the only way it can be less than 1 is if it gets closer to the x-axis when I go to the right, and the only way it's greater than 1 is when it gets further away from the x-axis when I go to the right, and then you can compare their relative values by thinking about green must have a larger value of b than blue does, because when I take one step to the right, it ends up higher than blue ends up. So really the same logic that we use down here should work on question 8, even though question 8 looks a little bit different. I'm running out of voice, but hopefully I can finish these last 2 problems. Question 9 just says find the equation of the graph sketched below. It's not the most interesting problem. I think what you're supposed to do on this problem is look for points that have integer coordinates. So use these 2 points. And maybe just using one of these points we can figure out A, and then maybe using both of these points we can figure out B. And remember, the equation is going to be AB to the x power. Question 10, same idea. Again, focus on the integer points. So I got this point right here and maybe this point right here. Maybe I can use this one to find A, and then I can use this one to find B. It's worth pointing out that these problems, question 9 and question 10, really could have been on the last homework assignment, right? I could have said an exponential function passes through the point 0, 5, and it passes through the point 1, 10. Find the equation of that function. And you'd be like, oh, this is the first type where I can use the shortcut. I can use this point to figure out A, and then I can use this point to figure out B. That stuff we did algebraically in 4.1, we can do geometrically in 4.2. And the reason I wanted to mention it this way is because I think that'll really help with question 11 here. So when you get to 11, you look at it and you're like, I can't tell what the y-intercept is right here. So how am I going to possibly answer this question? How can I figure out A if I can't look at the graph and tell what the y-intercept is? Well, don't focus on the y-intercept. Find 2 integer coordinate points. Looks like here's 2 right here. And then attack this in the manner of 4.1. I think this is really a 4.1 problem and not a 4.2 problem. This goes through the point -2, 1, and it goes through the point -3, 3. And maybe with that information, you could figure out A and B. So kind of a tricky problem, I suppose. Question 12 is just like question, whatever this is, 11. I don't like how these format, in that you can't look at it and tell what the y-intercept is, right? It's not even showing up on the graph. How am I ever going to figure it out? You don't need to get it straight off the graph. Just find 2 points with integer coordinates. So in this case, -5, 1 and -4, 4. And do this just like you did it before, right? In case you don't remember, y equals a times b to the x power. Take this one and make an equation. So 1 equals a times b to the -5th power. Then take this one and make an equation. 4 equals a times b to the 4th power. Then take these 2 equations and divide them. Take the one with the larger exponent and put it on top. So 4 over 1 equals ab to the 4th divided by ab to the -5th. The a's cancel out. I get 4 is equal to b to the 9th power. So b is equal to the 9th root of 4. Whatever number that is, I don't know what that number is equal to. But now that I know what b is equal to, I can use that to come up with an expression for a. From this equation right here, maybe, 4 is equal to a times b, which is the 9th root of 4, raised up to the 4th power. So if I want to know what a is equal to, I divide all this stuff over, and I get that a is equal to 4 divided by the 9th root of 4 to the 4th power. In other words, 4 to the 4/9 power. A lot of 4s and 9s going on in this problem. Once I know a and b, I can write y equals a times b to the x and get my answer here. The remaining problems, not super important. They're kind of some leftover stuff that I wanted to show you. The first one is get you comfortable with E. What you need to know about E is it's approximately 2.7. 2.718 if you want to be fancy. 2.71828 if you want to be really fancy. The idea is to sketch an approximate graph, and it doesn't have to be exact, but get something close to the graph of y equals e to the x. So the way to think about this is it's 1 times e to the x. The value of a is equal to 1. The value of b is equal to this 2.7-ish number. So its y-intercept should be at 1. And when I take one step to the right, the height should be like 2.7 or so, something like this. Use your graphing tool, go through these 2 points, and you'll see a graph that looks kind of sort of like, well, whatever. The graphing tool will figure out what it looks like, and you put that in as your answer. Then it asks you about domain and range. Again, this is like supplementary stuff. I don't really care about this. But if you think about this graph, you see that I can put any x value that I want into it. So the domain goes from -infinity to infinity. But for the range, only positive numbers can come out of this graph. This will never get below the x-axis. So the range is just all numbers from 0 to infinity. Question 14, which mercifully for me is the last one on here, asks you to sketch an approximate graph of y equals negative 2 times 1 over e to the x power. And I was afraid this would be too hard, so I gave you some hints here. I said, hint, plot the points corresponding with x equals 0 and x equals negative 1. Right? A is equal to negative 2, b is equal to 1 over e. What you need to know about 1 over e is it's approximately equal to 1 over 2.7 or so. And you're like, yeah, but what's 1 over 2.7? Well, we don't have to worry about it because the input-output pair that you might want to use is when x equals 0. If x equals 0, this whole thing's equal to 1. So we're going through this point right here, negative 2 times 1. And when x equals negative 1, we get 1 over e to the negative 1 power. But when you're raising something to the negative 1 power, you're taking the reciprocal of that thing. So we don't care what 1 over 2.7 is equal to, because 1 over 2.7 is just 2.7. Take that 2.7, multiply by this negative 2, and you get roughly negative 5.4. So we want to dot roughly here-ish. This graph will end up looking, loosely speaking, like that. And then finally figure out the domain and range the same way we did up here. That's all I got.